Hello, and welcome to our last video on partial fraction decomposition. Today we're going to tackle rational expressions when we have denominators that have prime quadratic factors. Now let's take a look. First off, is this proper or improper? Well, it's hard to tell in this denominator because we have a degree 4 up top, and what do we have on the bottom? Well, if we square the denominator, this would become an x to the 4th times x, or x to the 5th. So yes, the degree of the numerator is less, so it is proper. Next thing we want to do is factor our denominator. Well, it is. It just turns out we have a linear factor, and then we have a prime quadratic factor. Prime quadratic factor means it's not factorable over the rational numbers. So how do we handle this? Okay, first let's tackle our linear factor of x. Next we have a prime quadratic factor of this x squared plus 2. But you notice that it has a power of 2? So just like in the last video, we also have to account for maybe having a rational expression that has that power as well. Thus far, not much new. We have a linear factor here, so we put our constant on top. But this is not a linear factor denominator. So how do we handle that? We go to our step 4. When we have quadratic factors, our numerator has to be a linear factor. So it's not just a constant of b, it's actually a linear factor of bx plus c. So there's two variables in this one expression we're going to have to solve for. But wait, we have another quadratic factor here. So we're going to have dx plus e. We typically use capital letters to avoid confusion with our variables that we have going on. But if you count them, 1, 2, 3, 4, 5 different values we need to find. That might seem overwhelming, but let's take a look at what we need to do. Just like before, we're going to multiply by our LCD, which always clears out the denominator, and you're left with 7x to the 4th plus 23x squared plus 5x plus 20 equals. Now, this x and that x would cancel out, and we're left with a times x squared plus 2 all squared. Plus, we have a bx plus c linear factor, and one of these x squared plus 2 cancels out with one of these. So we're still going to have the x, and we're going to have one of these x squared plus 2. That's going to be a little bit of a handful for multiplication, but we might be able to do it off on the side. Plus dx plus e, and this x squared plus 2 squared would cancel out with this x squared plus 2, quantity squared, so we're just left with times x. Now, this is where we're really going to have to be careful of all of our Algebra 1 skills. So left-hand side is still 7x to the 4th plus 23x squared plus 5x plus 20 equals. Now, we can use our formula for squaring a binomial. You square the first term, get x to the 4th, but times a. So ax to the 4th. We multiply these two terms and double it. So 2x squared doubled is 4x squared, but times a. So plus 4ax squared. And you square the last term. So we end up with plus 4a. Next, we have to multiply, and we have 3 different things to multiply. I always like to multiply my binomials and then distribute this x through. So bx times x squared is bx to the 3rd times another x's plus bx to the 4th. bx times 2 is 2bx times another x's plus 2bx squared. C times x squared plus times another x is plus cx to the 3rd. And finally, c times 2 times another x is plus 2cx. Again, be very careful when you're doing your multiplication. And then distribute this x through. So plus dx squared plus ex. So now let's try to combine all of our like terms. So 7x to the 4th plus 23x squared plus 5x plus 20 equals. We got an x to the fourth term and an x to the fourth term here. So we get an a plus b x to the fourth. We only have one x to the third term. So plus c x to the third. That's nice. But we have 1, 2, 3 x squared terms. So plus 4a plus 2b plus d x squared. And we have, look at that, 2 x terms. So plus 2c plus e x. And the only constant term we have is this 4a right here. So plus 4a. It's going to be very important that you organize things. So let's start to equate our coefficients. So our quartic term of a plus b better equal 7. Our cubic term, there is no cubic term. So what does c equal? Yes, that's right. C equals 0. Yay! That was a fun one. Our quadratic term, a little bit more involved. 4a plus 2b plus d better equal 23. Our linear term, 2c plus e better equal 5. And our constant term of 4a better equal 20. Well, we already know c, so we plug it in here. 2 times 0 is 0. So guess what e equals? 5. Well, that was nice. If 4a equals 20, then a equals 5. So very quickly, out of the 5 variables we're searching for, we already know 3. But if we know a, we can plug it back in over here. 5 plus b equals 7. So b better equal 2. And we're down to our last one. So 4 times 5 plus 2 times 2 plus d equals 23. This is 20 plus 4. 24 plus d equals 23. Or d, in fact, equals -1. So initially that was overwhelming, but we were able to handle it. Watch all your algebra. Now let's put it all together. So we start off with a over x, or 5 over x, plus bx plus c. b is 2, so 2x. There is no c, so 2x over x squared plus 2, plus dx plus e. So that's -x plus 5, all over x squared plus 2 all squared. And this is how we handle not only prime quadratic factors, but also if we have repeated prime quadratic factors. I hope you enjoyed this. Good luck with the problems that you're going to go on.